Okay, thank you everybody. Our next speaker today is Ramesh Singh, who is a professor in the School of Earth and Environmental Sciences at Chapman University in California. Ramesh?
Thank you, Jennifer. This is my great pleasure to give a talk today at the second Giovanni workshop. And I'm going to talk about the NASA Giovanni tool, which is a unique tool to understand land-ocean atmospheric coupling associated with the natural hazards. And natural hazards are occurring throughout the globe, anytime, day and night. Okay. So welcome to everybody at the 2014 Leptoukh second online Giovanni workshop. And Greg, smiling face always, and I was meeting him at the George Mason University when I was there, and also at the fall meeting, AGU meeting, okay. And the last time I did talk to him in 2010, December AGU meeting, and I discussed with him about the NASA Giovanni workshop, training workshop for India, and he was very much interested to come to India and give a training workshop. So I thank my students, friends, colleagues with whom I have used the NASA Giovanni tool for the study of the land, ocean, atmosphere. Okay, and I also thank my current and past undergraduate students of NV 103 course at the Chapman University, and I also thank to participants of the Coast Training Workshop, which I had organized at Chl-a University in January 2011. And participants of a International Center for Theoretical Physics workshop, which I had organized on remote sensing, where I gave a demonstration to study the satellite data for the land, ocean, atmosphere applications. Okay, so let me start talking about the Earth system science. And the Earth, which is 4.5 billion years old, and we have a lithosphere, hydrosphere, atmosphere, biosphere, cryosphere. Okay, and what we see that something happens on the Earth, on the land, the ocean gets affected, atmosphere gets affected. When something happens on the hydrosphere, then the land gets affected, atmosphere gets affected. Okay, so this is a very strong coupled system where we have land, ocean, atmospheric coupling, and all these couplings are associated with all kinds of natural hazards, whatever you talk about, earthquake or hurricanes, typhoon, cyclone, or even the dust storms. Okay, the land, ocean, biosphere, atmosphere gets affected. Okay, so now the question is how the satellite data is helping us to study this coupling. Okay. And now we have a multi-sensor data, which are providing information about the land cover, ocean, atmosphere, cryosphere, and meteorological parameters, which is a new thing. And now we get information at a different pressure levels. Okay, so one can use all these data to study the land, atmosphere, ocean, hydrosphere coupling. Okay. So monitoring of each sphere is important, and the multi-satellites provide data around the globe. And the NASA Giovanni is a unique tool, has emerged as an important tool in better understanding of the Earth processes. Okay, and the life has become very, very easy with the Giovanni tool. Okay, so I'm going to emphasize today about the natural hazards. Okay, and how NASA Giovanni tools is providing all kinds of data to understand the all kinds of natural hazards. And everybody knows what are the natural hazards. Okay, it is related with the atmosphere, it is related with the land, it is related with the ocean, all kinds of natural hazards. And there's satellite data, whatever we get about the land, ocean, atmosphere, biosphere, cryosphere, okay, these are provides a strong coupling associated with all kinds of natural hazards. Okay, how we should, how we are getting the data of atmosphere, land, ocean. These are all, we have a Buoys data, we have satellite data, we have radio sounding data, we have ground observations, and one can try to integrate all kinds of data to understand all kinds of natural hazards. Okay, so I'm very happy that now we are using NASA Giovanni tool. Okay, and NASA Giovanni tool, you can see this, it integrates all kinds of satellite data, okay, and all kinds of parameters which people are trying to use. And then now our life has become very easy with the NASA Giovanni 4 version, okay, and directly you can analyze the time series, you can put all the data directly in Excel files. Earlier it was not there, but now with the very small effort, one can try to study this. One can try to make a own plot, okay, to understand this. So I did the workshop at the International Center for Theoretical Physics. This institute is mainly for the developing countries, and I, together with the other two directors, we had organized this workshop. And there were 85 participants from the developing countries. Okay, and this was the first time I demonstrated how the NASA Giovanni tool can help us in understanding the chlorophyll blooming, which is associated with the coastal areas. Okay, and then also I try to show them to the participants how ground observation, how the satellite observation, one can try to integrate using the NASA Giovanni tool. Okay, so here I try to use the GPS water vapor and the rainfall, ozone, and the satellite parameters, okay, to show the students. Okay, and they were very happy. And then I had organized the Coast Guard training workshop, and in this workshop I wanted to take Greg, but he was busy in taking care of his parents, and he said, Ramesh, it is not possible for me. So I had organized this training workshop for 2 weeks, and there were also the scientists from NASA, ESA, and other countries. They went with me, along with me, and they gave a series of lectures. And we gave how one can use the NASA Giovanni tool to understand the Earth processes. Okay, and there were the participants from Bangladesh, India, and China. So the workshop was very successful, and I am happy that people are using NASA Giovanni tool, and they are in touch with me. They contact me for any such kind of problems. Okay, so I'm with the Chapman University as of 2009. And I teach Introduction to Earth System, Introduction to Natural Hazards, and Earth System Processes at the undergraduate and graduate level. And I try to show them Giovanni, NASA Giovanni tool, to study the land, ocean, atmosphere, okay, and mainly with all kinds of natural hazards, especially dust, earthquakes, volcanoes, and the students are very, very excited, okay, to learn this. So how NASA Giovanni can help us in understanding Earth system processes related to natural hazards. Using NASA Giovanni, we can get the information about the land, ocean, biosphere, atmosphere, okay, and it really, one can understand the dynamics of any location. So here I'm going to more emphasize about the natural hazards. And you can see the plate boundaries, you can see the earthquakes, the active volcanoes, okay, occur along the plate boundaries and also along the ocean coast, okay. So the yellow and the red one, are the location of the active volcanoes, yellow one are the location of the earthquakes, okay. So here, the earthquake phenomena. Earthquake occurs 5 kilometers beneath, and there are the acoustic emission, electromagnetic emissions, okay, and these emissions affect the surface temperature, affect the meteorological conditions, and I would like to emphasize here that if something happens inside the earth, if there is a water is present almost everywhere, and some water are shallow, some water is deeper, and then it fluctuates. Okay, the water table gets fluctuated by the stress buildup, by the earthquakes, and then what happens? There are the gas emissions from the porous spaces, okay, and these gas emissions can affect the skin temperature of the earth, and also it can affect the air temperature, okay. So I'm going to demonstrate to you that how we have found this enhancement of the skin temperature, enhancement of the surface temperature, okay. This is the Venture earthquake, which occurred in 2008, May, which killed so many lives and damaged the buildings and the properties, okay. And here we try to analyze the temperature at a different pressure level, and also the surface skin temperature and the surface temperature at a different pressure level for different days, okay. And all the details of this study is published in the International Journal of Remote Sensing. There was a special issue of 2010. One can find this study, details of this study, and one can see that relative humidity also change, okay, and the relative humidity change at the pressure level, okay. And so here I'm trying to show these for the different days, and we found that one can get the anomalous changes in the relative humidity prior to the earthquake, okay. So what are the possible causes for the change of the surface temperature prior to an earthquake? This is the main question people they ask, because the seismologists say they did not find any change in the ground temperature, in the borehole temperature, okay. But now there are studies which have shown that the ground temperature does change, okay, even prior to the earthquake. So here in the Gujarat earthquake, which occurred on 26th of January 2001, we try to analyze the carbon monoxide. Okay, I'm talking only carbon monoxide because up to now we have a carbon monoxide gas with the moped and the airs, and not other gases. So in the carbon monoxide, when we carried out this analysis, we found the sub-change, anomalous change prior to the earthquake, and also one can see the changes also occurred at a different pressure level. Okay. So when the carbon monoxide increase, and this increase could be related with the changes in the skin temperature and air temperature. Okay, so the theory what we are relating that in an earthquake, the water fluctuates. When the water fluctuates, the pore spaces where the gases are filled, the gases start emitting, and you can find all types of gases. So here, using satellite sensors, we try to monitor the carbon monoxide. Okay, so this is what I showed you, that the enhancement of the carbon monoxide. So changes in the IR temperature and enhancement in the carbon monoxide concentration could be due to water table fluctuations that could release different kinds of greenhouse gases. Still, we have to see, we have to check, and there are observations in the Kobe earthquake where they found enhancement in the NO2 concentration. Okay. So here we carried out a study related with the Haiti earthquake of 12th January 2010. And you can see the aftershocks data, and this is a region where we try to analyze all kinds of earthquake satellite parameters. So this was the epicenter, and the Haiti earthquake was close to the ocean, and here I'm trying to show you the surface air temperature, and the surface air temperature 1 day prior to the main earthquake event. There was the anomalous low peak we observed in the surface air temperature. Okay, and same thing you can see here. I'm trying to show for the different years. And the 2010 when the earthquake occurred in Haiti, you can see the anomalous lower peak of the temperatures. Okay, and again at a different pressure level, one can see this. Okay, anomalous temperatures, low values, one can see over the Haiti epicenter. And this is the relative humidity. So we try to see that the higher temperature change. We also try to see that the relative humidity changes, okay, and we have found all these parameters change related with the number of earthquakes, okay. And one can see the air temperature, which shows a few days, 1 day prior to the earthquake, air temperature decrease. Okay, and here is again the relative humidity for the different years, and we found the changes in the due to the atmospheric perturbations. So the earthquake lead to give rise to the atmospheric perturbations, and as a result, one can find the changes in the relative humidity. Okay, so, see this again at a different pressure level, and you can see how the temperature, the relative humidity shows the anomalous behavior at a different pressure level on different days prior and after the earthquake. Okay. This is the surface latent heat flux, and the number of scientific groups, they are studying the surface latent heat flux. And in the 2004, we established that the surface latent heat flux gives an anomalous behavior prior to an earthquake. So we saw a higher anomalous peak of the surface latent heat flux prior to earthquake. This is again, one can clearly see the surface latent heat flux peak, which is about 2 sigma, more than greater than 2 sigma. One can find associated with the Haiti earthquake. Another interesting observation, we have found that the total ozone column change and increase soon after the earthquake, and you can see here I'm trying to show a special pattern of the total ozone column. Okay, this we found in the Denali earthquake earlier. This time is a Haiti earthquake, and there are some other scientists. They have found a similar behavior. Okay. So we wrote a paper on the Haiti earthquake, which was published in Natural Hazards and Earthquake System Sciences, and we always acknowledge the efforts of the NASA Giovanni team for providing all kinds of data. And now I'm going to talk about the earthquakes which occurred very close to San Andreas Fault and very close to us in La Habra, and the Chapman University very close to La Habra, and this earthquake occurred on the magnitude 5.1, 2 kilometers east of La Habra, okay, on 29th March. And the earthquake was only 4.8 kilometers deep, and we try to use the NASA Giovanni tools to study the chlorophyll A product. Also, we try to use the sea surface land temperature using Giovanni, the meteorological data, and we also use NCEP Reanalysis, the surface latent heat flux, and then also the Buoys data. Okay, and we try to integrate the ground observation, the model data, meteorological data, and the satellite data. Okay, so this is why I'm trying to show the Buoys data. Okay, we are lucky that there was 1 or 2 buoys near to Orange County coast and Los Angeles coast. So we try to integrate all kinds of data. So here, every time whenever an earthquake occurs, the USGS come out with a shake map, and one can see the shake map with the yellow background, okay, and the yellow background shows this shake map, and then I try to overlay the aftershocks data, okay, and one can see the circle, white circle, these are the aftershocks data. of the earthquake. And here, these are the aftershock data, and some were pre-shocks data. Aftershocks, this was a 5.1 magnitude earthquake, and after that, there were a series of aftershocks. And here are two buoys. There are so many buoys, okay, and we have considered two buoys, and this is one buoy's number, this is another buoy's number. So we try to study all kinds of data, and since the satellite data is the low resolution, and here buoys data we found very closely spaced. And one can see the seawater temperatures, the seawater temperature prior to the earthquake. You can see anomalous peak of the seawater temperature, and this is the water temperature. This is the diurnal variations. This is the buoys data for March 27, 28, 29. One can see that the March 29 sea surface temperature, water temperature data shows the anomalous behavior. Okay, so here again is the pressure data on the surface measured by the buoys. This is diurnal variation, March 27, 28, 29. Similar to the temperature, water temperature, March 29th is showing different behavior compared to the March 27th, 28th. Okay. And you can see here the wind speed. Wind speed is also showing anomalous change. And of course, which is very obvious, when the water wave can change some anomalous behavior, the water wind speed can also vary. Okay, it is all related with that. So here is the surface latent heat flux. We have taken now one can take the surface latent heat flux using Giovanni, but we took directly from the NCEP Reanalysis. And here I'm trying to show the one day before, a few days prior to the earthquake, we found the anomalous behavior of the surface latent heat flux. Okay. This is the spatial temporal behavior of the surface latent heat flux along the Los Angeles coast. Okay, and one can try to see there is a change in the highlighted the grid about the surface latent heat flux. And this is the chlorophyll concentration from the Moody's chlorophyll data from Giovanni weekly data. We try to show that how the chlorophyll concentration is changing along the coastal region. Okay, and this is again the time series. You can see that prior to the earthquake, we found the anomalous change in the chlorophyll concentration. Okay, so of course, when the temperature change, chlorophyll concentration change, it is all related. And why it is happening, we found that prior to the earthquake, there was an upwelling. When there is an upwelling, there is a water mixing, nutrients come up, okay, which can give the anomalous behavior of the chlorophyll concentration. Okay, so the last case I want to present is the Chl-a earthquake of 6th April 2009. These are the location of the epicenters. Okay, and here the Luca, he published a paper in Geophysical Journal International, and they have shown the anomalous thermal infrared anomaly. Okay, and why this anomaly caused, and this I'm going to demonstrate to you. And we carried out the analysis of the carbon monoxide and total ozone column, and we found prior to the earthquake, we found the enhancement of the chlorophyll concentration. And here I want to show the very unique pattern of the total ozone column. And this pattern we have found in so many earthquake cases. Okay, so the total ozone column changed after the earthquake, but the carbon monoxide, the temperature changed prior to the earthquake. And if it is happening, and which is almost associated with the fluctuation of the water table, and then the temperature enhance, which is found by other people. So here my conclusion is that the NASA Giovanni tool has emerged as an important tool to study and understand Earth's system processes associated with the natural hazards at local, regional, and global scale. Okay, and in my talk, I only talked about earthquake, but similar to land-ocean atmospheric coupling is found associated with the volcanoes, volcanic activities, associated with the dust storm activities. Okay, so NASA Giovanni tool is very, very important, and we suffered the last year when there was U.S. government shutdown, and I, as a professor, I did not find the data to work with the students during the semester. So we have to do something, okay, and I want that the NASA should act if the situation arises like this, and if we should get all the data through NASA Giovanni tool. So thank you very much. Thank you.
Okay.